Welcome, everyone. Oh, wow. That was not where I wanted to send it. Let's send this to everyone. There is the link to the slides. They are online right now. You can grab them at robrich.org. I'm really excited to be able to present here at ACCU, and this is going to be a really fun discussion. Everyone will then start with, my slides are online, but you can go to robrich.org right now. And once you click on robrich.org, you'll get to this page and you'll get right here to the presentations. Click here on presentations, and here's JavaScript, the grumpy parts. Here's the slides. They are online right now. Feel free to get ahead. Feel free to heckle me about the slides I haven't used yet. This will be a really, really fun discussion. While you're here on robrich.org, click on About Me, and you'll get to this page that'll talk about some of the things that I've done recently. I'm a Microsoft MVP, a friend of Redgate. I'm a developer evangelist for SingleStore. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software. We start building free software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here or wherever you're connecting from, hit me up on email or Twitter, and let's get philanthropy installed in your neighborhood too. Some of the other things that I've done, I worked on the Gulp project as a core contributor in version 2 and version 3. That was fun. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. Let's dig into JavaScript, the grumpy parts. Now, the cool thing is with each of these slides, if there's any blue links, you can click on those to get to the site for more information. So this can be a great place for grabbing notes or digging deeper into the concepts that we've got. Grab the slides at robrich.org and you can follow along. We talked about this guy. I want to thank Jonathan Mills. He built a similar talk called A Guide to JavaScript Scary Side. If you've not seen John Mills' talk, he's a great speaker. And this talk definitely goes farther and in different directions, but thank you to John, who really started me on this path. What's going to be cool is I'm pretty sure we're going to hit edges in my knowledge as well, where my answer is going to be, I don't know. JavaScript is wonderful and weird. And sometimes, yeah, the answer is, oops. So definitely poke at it. Let's see if we can find the edges of my knowledge and yours and see if we can learn stuff together. This will be really fun. So let's talk a little bit about JavaScript. JavaScript is wonderfully weird, and we like to poke at it for being, just really strange. But let's look at those things a little bit deeper and see if we can understand why they came to be. If we can understand how JavaScript works, maybe it'll become less mysterious, less weird. So Brendan Eich. Brendan Eich wrote JavaScript as a really quick experiment in 10 days, 25 years ago. I don't know about you, but the code I wrote 25 years ago was pretty awful. So the fact that we're now all talking about JavaScript, his 10-day project 25 years ago, is pretty amazing. If you want to learn more about Brendan Eich, you can read or watch more about introducing Brendan Eich. He is a really cool guy. He created what was then LiveScript as a mechanism to kind of put Java or Lisp into the browser. JavaScript. The cool thing is that we now have a bunch of JavaScript runtimes in various places. In Chrome, we have V8. That's also the JavaScript engine inside Node. In Firefox, we have SpiderMonkey. In Safari, we have JavaScript Core. And in older versions of IE, we have the Chakra JavaScript engine. Now, what's really cool is that each of these engines cloned JavaScript with amazing fidelity. So we don't really have any weirdness in how JavaScript behaves. Back in the day, we had a lot of differences in JavaScript, but it wasn't JavaScript. It was in the document object model, the DOM, the way we addressed HTML elements. So we had a lot of weirdness in how we connected to the HTML, but the JavaScript engine itself was amazingly compatible. JavaScript was copied with incredible precision, including the bugs. So all of the engines function pretty much the same. If we can write JavaScript, it will work anywhere. Well, there may be new features that might not have been implemented in a particular JavaScript runtime yet, but we won't get different calculations or different behaviors based on JavaScript engines. The methodology of JavaScript. JavaScript was invented as a language that runs over there. As a developer writing JavaScript, we don't ship a compiled binary like we would in other languages. Rather, we ship our source code to the browser. And the browser running over there goes and executes it. Well, because it's running over there on the user's machine, far away from where the developer wrote it, then the goal is to keep it running as much as it possibly can. Now, that means that the browser needs to forgive a lot. The JavaScript runtime needs to forgive a lot so that we can try to keep the system running whenever we can. A great example of this is if JavaScript finds a compile error, it will back up and see if it can put in a semicolon to split the lines apart. Well, this semicolon insertion can be really powerful in making our code work, even if, well, we didn't type it correctly, but it can also lead to some really random bugs. If you've ever put the curly brace on the next line, JavaScript is really helpful at changing the meaning of your code. So to that end, does JavaScript require semicolons? Well, technically, yes, it does, but it's really good at putting them in if we haven't. And so that's why some people in JavaScript code without semicolons. The compiler does require semicolons, but the JavaScript runtime is so forgiving, it may put them in place if we didn't intend them. So that's what yields really weird behaviors. Let's take a look at some of those weird behaviors. If you've not seen this, definitely pull up these slides at robrich.org and click through this video. The JavaScript WAT video is really entertaining. It's all of JavaScript's wacky quirks. And I love this telling of it because this is Brendan Eich playing that video as part of his talk. It is really fun. Click play here and dig into the JavaScript WAT video. I'm not going to duplicate that video, but let's look at a few of those things that are kind of weird. Undefined. Well, undefined is a constant in JavaScript, but JavaScript didn't really have the concept of constant. So it's basically just a variable. And if you had undefined and you, I don't know, defined it, well, now undefined is defined. And all of the places where we go check to see, is this undefined, will no longer work. Now, in more modern versions of JavaScript, we've kind of baked in that undefined should be a constant and shouldn't be changed. But yeah, undefined could have been defined, and that's kind of weird. Here's another one, type of null. Well, I would think that it would be undefined or null, but type of null is object. Well, that kind of makes sense. It's, in the object realm, it's more closely associated to objects than, say, numbers or dates or other things. So, okay. But yeah, maybe this is a bug. It was only 10 days, 25 years ago. So yeah, that could be kind of weird. Type of nan. Now we would expect not a number to be, well, not a number, but actually type of nan is a number. Should it be object? Should it be undefined? Well, it is kind of in the numerical groups. So maybe this is a bug. Maybe this is just an easy organization for Brendan Eich back in the day. Not sure, but yeah, type of nan being a number. It's like, well, I kind of want to go check to see if it is a number. And if it isn't a number, I don't really want it to be of type number. So yeah, JavaScript is weird. Let's unpack this a little bit and let's look at the compiler. Now, the JavaScript compiler is wonderful and deep. It is a two-pass compiler. The first phase of the compiler will go look for variable declarations. When it finds variable declarations, it will allocate that memory and be able to then run when that content is available. The next phase is the execution phase, where it goes through each line of code and it executes it. Now, this is definitely an oversimplification because modern JavaScript compilers do all kinds of things about compiling quickly and then compiling more deeply once we have more context around it, and maybe not compiling paths until they're needed so that we can just drop unused code. There's a lot that goes into modern JavaScript compilers. But what's really cool is they still kind of work in this two-phase mechanism. First, it'll go look for all the variables to declare. And second, it will go execute all the lines. Now, knowing this, we can look through some code and we can understand how it behaves in really interesting ways. If you want to learn more, grab these slides from robrich.org and you can click through to either read or watch more at each of these blue links. So let's look at this code. Now, here's a function. I call this function main from down here. And in this main function, we will define we'll console log foo, we'll define foo inside this curly brace, and we'll console log foo again. What happens here? Take a minute and think through it and see if you can figure out what this code will do. Now let's think like the compiler and see if we can figure it out. So first phase, it will look through this code looking for variable declarations. In that first phase, we see this var foo. Okay, so let's set a foo variable in this scope. Now in JavaScript, by default, variables are scoped to functions, not to curly braces. So this foo variable is scoped to this main function. Okay, that's the only variable that we've got defined. Second phase, let's go look through the code and execute it. We'll call the main method. Now we're going to go console log foo. Well, we've already defined a foo variable in the scope. We haven't set its value yet. So here's that foo variable, and we'll console log it. Right now, it's undefined. Now, if true, we will go set that foo variable to bar. Recall that we already defined it in the first phase. So now foo is equal to bar. Let's console log foo, and we've got bar. So we'll get undefined and then bar. Let's take a look at that. In effect, it behaves kind of like this, where it kind of yanks the foo declaration up here. Well, kind of. That's variable hoisting. And well, variable hoisting is a lie. It's a lie that we tell ourselves so that we don't need to pay attention to this two-phase compiler. It's a lie that works in most cases. If we can think of a variable getting hoisted to the top, then we can kind of, well, think about it as one shot. Variables don't actually get hoisted. They just get defined in that first phase of the compiler. As we understand the compiler, now we can understand how variable hoisting works. Well, the lie that we tell ourselves so that we can believe about variable hoisting. It is a really helpful mechanism that we've invented to understand JavaScript's behavior, but variables don't actually get hoisted. Rather, they get defined in that first phase of the compiler. So as we think like the compiler, now we can say, okay, so first phase, we go grab this foo variable and we define it. As we run, we start by executing this. It's undefined. We haven't set its variable. We haven't set its value yet. Then we set it. Then we console log that value. So we get undefined and bar. Let's copy this code and set it into VS Code. I'm using this really cool extension that I enjoy. Let's see if we can find it in a second. Quokka, there we go. Quokka. It's a really fun extension that will run code as we execute it. So I'm going to save, and it's going to go run all this code. We get undefined, and we get bar. That's cool. So if we were to say, define it up here, foo equals foo, and save it. Now we get foo and bar. That's cool. Let's use this extension so that we can go verify our assumptions in a lot of places. Scope. Let's talk about variable scope, and let's define and undefine variables at various scopes and see how they behave. So we had this function where we had this bar function and we defined things. Let's define these two variables, foo and foo, outside here. Take a moment and think through this function. What's going to happen here? Now, let's think like the compiler and see if we can figure it out. Recall the two-phase compiler. The first phase, we're going to go look through and define variables. We've got this foo variable, so let's set that one aside. We've also got this foo variable. Let's set that one aside. We know that variables are scoped to functions, so this, maybe we'll call it foo2 or inner foo, is scoped to this bar function, and this foo is scoped outside. Now, is this the global scope, or is this inside of a different function or inside of a different file? We don't know yet because we only have this, but we do know that this is an outer scoped foo and this is an inner scoped foo. Okay, that was the first phase. Second phase, let's go execute stuff. So we start off, we set the outer foo to bar. Then we call the bar function. Here's our bar function. Now we set the inner foo to baz. If true, we'll set foo to bam. We go looking for a foo variable in our current scope. Now variables are scoped to curly braces, or not to curly braces, but to functions. So we find this foo in our inner scope, and we'll set that from baz to bam. Console log foo, and we console log bam, or baz rather. So we've got baz here. Now we leave our curly braces. Variables are defined to functions, not to curly braces. So we console log foo, and foo that we set right here to bam. So we get bam and bam. And now we leave this scope. This inner foo is gone. Now let's console log foo. We go looking for a foo variable in our current scope, and we find one right here. So we get bam, bam, and bar. Let's copy and set this into place in our tool and make sure that we got that answer right. Bam, bam, and bar. Is that the answer that you got? That was cool. Thinking like the compiler, we can kind of think through this and see how defining variables in various scopes works. Bam, bam, and bar. Nice. Now let's modify things a little bit. Instead of defining the variable here, let's define it here. Think through this project, this code. What will happen? Now let's think like the compiler and figure it out. First phase, we go defining variables. Here's the outer foo, here's the inner foo. We've got both of those variables defined. Now let's run. We're gonna set our outer foo to bar. We're gonna run the bar method. We set our inner foo to baz. Hey, is it undefined yet? Well, we can play the variable hoisting game, but we know that it was just defined in the previous scope. So our inner foo is set to baz. Inside our loop, we'll set it to bam. We'll console log that inner foo, that's bam. Console log our inner foo again, that's also bam. And console log our outer foo, which is still bar. Bam, bam, and bar. Is that the answer that you got? I love that we can think like the compiler and understand how JavaScript works so that the weirdness becomes less weird. We understand why it works this way so that we can make decisions on how to code it. Now, granted, defining these variables and using it this way is probably not very descriptive. If you do this in your production code tomorrow, yeah, don't. Let's do another one. Now, in this case, we've chosen not to declare the variable here nor here, but we still declare it out here. What happens in this case? Let's think like the compiler and figure it out. First phase, let's go look for variable declarations. We see one, this outer foo. Next, let's execute. We set the outer foo to bar. Then we run the bar method, and here we're looking for a foo variable. Is there a foo variable defined in our current scope in this function? There isn't. So let's walk up the scopes and see if we can find one. Well, we find this outer foo, and that's a variable defined as foo. So now we set it to baz. It was bar, now it's baz. Now it's bam, console log bam again. And now that we're done with the function, let's console log this outer foo again, and we get bam, bam, bam. Is that what you got? That two-phase JavaScript compiler can do some interesting things. Let's do it again. Now, in this case, we're not defining the variable at all. Now, we're not in strict mode. What happens here? Let's think like the compiler and figure it out. So first phase, we're going to go look for variable declarations. In this case, there aren't any. Okay, second phase. Let's go execute it. We're going to try and set this foo variable to bar. Well, is there a foo variable declared in our current scope? No. Let's walk up the scopes and see if we can find one. Is there one in our outer scope? Is there one in the global scope? Let's assume that there isn't. So JavaScript, being the helpful run over there compiler, says, well, let me go create you a variable. I'll create a variable in the global scope. I'll call it foo. And now we have that variable. Very nice. That was defined in the second phase. Now we'll set it to bar. As we run our function, we'll now go looking for a variable in our current scope. We don't have one defined. We don't have a variable defined out here. So we'll keep walking up until we find that same global variable named foo. We'll set it to baz. We'll set it to bam. And as we walk all the way out, we'll get bam all the way through. Now, the cool part is that JavaScript didn't fail. It helped the user to be able to run our application. But we automatically defined a global variable. Well, what if I had defined it as I? And what if I was also using your library and you defined it as I? Well, now we've started to overwrite each other's variables. Oops. Defining variables very succinctly allows us to avoid that automatic global variable creation. Let's do it again. But in this case, we're going to assign foo to a bam variable. What happens in this case? Let's think like the compiler and see if we can figure it out. Our first phase, we'll go look for variable declarations. We've got this foo variable defined out here. Second phase, let's go execute it. So this foo variable will get set to bar. And then we'll run our bar function, set foo to baz, walk in here, and we'll set foo to bam. Oh, let's go find the value of bam. Do we have a bam variable in this current scope? We don't. Let's look in this outer scope. Do we have a bam variable? We don't. Let's keep walking up. Is there a bam variable defined in the global scope? There is not. So we can't get the value out of this variable that doesn't exist yet, and we get a reference error. Bam is not defined. Now, when setting variables, they will automatically get created. The compiler can forgive that. But when getting values of variables that don't exist, we can't. They just don't exist. We can't get that value. So we get a reference error. Setting undefined variables creates them. Getting undefined variables throws a reference exception. As we think like the compiler, that makes sense. But that is kind of weird. Now we understand why. That's cool. Let's do it again. But now, instead of defining these, we're going to use let. Now, let and const are new in ES6, ES 2015, and they behave a little bit differently. var is bound to a function scope. Let and const are bound to curly brace scope. So let's see what happens here. Think through this example. What's this going to turn out into? Now let's think like the compiler and see if we can figure it out. First phase, we go define all of our variables. We've got one here. We've got one here. Now that we've got our variables defined, phase 2, let's execute. Our outer foo is set to bar. Now we're going to run our bar function, and we're going to go look for a foo variable. Now, curly braces define these variables, so this inner foo isn't available yet. It's inside this block scope. So we go looking for a foo variable. There isn't one in this scope, so we'll go find one in an outer scope. Hey, we've got this one. Let's set it to Baz. Okay, now inside here, we're going to define a new variable and this inner foo and set it to bam. We'll console log foo. That's now bam. Leaving this curly brace, this inner foo goes away, and we now have this foo. Well, this foo, there's no foo defined in this scope. So we'll looking in the outer scope, we have this foo that we set to Baz here. So we've got bam, Baz, and then outside the function, Baz. That's cool. Now that's one of the ones where I have to go double check myself because it gets a little weird. Let's set this in place. I love this extension that goes and figures out all the things. Yep, bam, Baz, Baz. I wish they had comments or something highlighting what that variable was, but I do like that they've got this in place that shows us where it's defined. Yeah, that was kind of weird, but I love that with this now curly brace scoped variable, we now have more predictable behavior. It kind of matches our assumptions with other C-style curly brace languages. Okay, let's take it a step further and let's not define this one out here. Now what happens? Let's think like the compiler and figure it out. First phase, we'll go look for variables to define. We've got this one foo variable right here. We'll set that one aside. Second phase, let's execute. This is a comment, so we do nothing. Run the bar function. Now we're going to go look for a foo variable. There isn't one in this scope. This let, pardon me, this let is inside this curly brace, so it's not available. We'll go looking in our current scope. We can't find one. Go look in the outer scope. We can't find one. We'll keep climbing up scopes until we get to the global scope. There's no foo there. So the compiler will create one for us. We now have a global foo variable, and we'll set it to Baz. We've got this inner foo. We'll set it to bam. We'll console log it. That's bam. We'll console log this foo variable. We'll go look for a variable, and we'll find that same global variable that we defined when we created this line. So bam, and then Baz. And now out here, we'll go looking for a foo variable again. Now we don't have a foo variable defined in this scope, so we'll keep walking up scopes until we find that global variable that got defined on this line. Now it's a global variable, so when we output it, we'll have that value. Bam, Baz, Baz. There was no variable defined in this scope, but we got the value out of it. Yes, automatically creating global variables is weird. Let's do this. We've got a let here and a let here. What's going to happen in this case? Let's think like the compiler and figure it out. So in our outer scope, we do nothing. It's a comment. We'll call our bar function. We have a let. So this foo variable is created when we, in that first phase. We've now set its value to Baz in the second phase. Inside here, our inner foo is set to bam. So we'll console log that inner foo, bam. Outside this curly brace, the let variable goes away and we console log foo, that's Baz here. So we got bam, Baz. And now we come out here and we're looking for a foo variable. We don't find any in the current scope. Both of these variables escaped or were set aside once that variable, once the function finished. So we go walking up, even in the global scope, there isn't a foo variable. And we get a reference error, foo is not defined. Because we defined these variables in these scopes, we're trying to read a variable that doesn't exist. Yeah, that's weird. So how about const? Now, the cool thing about const is its value doesn't change. So what happens in this case? Let's think like the compiler and figure it out. const foo. So we're going to define this variable. Const foo will define this variable. That's the first phase. Second phase, let's go execute it. Foo equals bar. We'll run our bar function. And now we set foo equals to baz. Let's go find that foo variable. Now this foo isn't available. It's inside of a curly brace and it's scoped to a curly brace because let and const are. This outer foo, we don't have a foo defined inside the bar function. So let's go to our outer scope. Oh, we've got this foo. That's the variable that we want to change. And we can't change it. It's a const. So we get a type error assignment to a constant variable. That's perfect. Now, a word of warning here, if we're using Babel to transpile our ES6 code into ES5, basically there is no const in ES5 and it switches this from a const to a var. What would happen in that case? Well, it would assign it just fine. So if you are running an ES6 or later comparable browser, consider modifying your Webpack config to use Babel and not transpile to ES5, but to ES6. Now you keep const. That's pretty cool. So we got to see how defining and not defining variables in various scopes worked. We looked at how the compiler did interesting things. That two-phase compiler is really interesting. We like lying to ourselves with the hoisting concept, and the analogy holds, but it doesn't actually work that way. Let's look at another example, this. This in JavaScript is, well, kind of weird. Let's look at this. This is the thing to the left of the dot. And I love this definition because it is so elegantly simple. If you want to grab these slides from robrich.org and dig into more about why it is the thing to the left of the dot. So here's some code where we're going to console log this.name. And we're going to look at what is this in various circumstances. Well, we have a name right here. We'll set name to Ninja. And when we call speak, well, what is this? Well, it's the scope of this function, the scope of this execution, probably the global scope if we're in a browser. So what's this.name? Well, it's Ninja. Okay, so we speak and we get Ninja. We've defined object 1 and object 2, and we're just grabbing the speak method. Yeah, we could have defined it in both places, and that would have been easy enough, but functions getting plucked into objects, we can do that too. So now when we say obj1.speak, we call obj1's speak method, and so when we call this.name, we get doctor. When we call obj2.speak, we call speak on obj2 and we get Skywalker. So Ninja, Doctor, Skywalker. Yeah, this behaved as we expected. It was the thing to the left of the dot. Now, the only part that was weird was the left of the dot in this global case where we looked in the global scope. That's cool. Ninja, Doctor, Skywalker. Let's level up. Now, variables are first-class objects our functions are first-class objects in JavaScript, so we can pass functions around as variables. So I'm going to take object1.speak and I'm going to assign it to this obj_speak variable. Okay, if I do obj1.speak, that is as expected. I call speak and it uses this, which is the object, and I get doctor. So obj1.speak is doctor. Now, what's the thing to the left of the dot here? Yeah, technically it was a function baked into this object, but it isn't anymore. Obj_speak is the global object right now. And so when we get this.name, we get an error. Or, well, if we've defined name anywhere, of which DOM does, we'll probably get blank or undefined. Doctor and undefined. I'm assuming that we're running in the context of a browser here. Now, obj_speak isn't bound to the object anymore. It's just a variable out in the middle. And that isn't necessarily what we want. Let's create another scenario where we have a click button. Okay, so we say document.get by ID. We go grab the button and we add an event listener for our click event that calls the speak method. Now, when we're in this speak method, we have a console log this.id. Now I know that I have an ID because I got that button by ID. So when I click it, this speak method, what's the thing to the left of the dot? Well, here's the dot, here's the thing, it's the button. So when we click the button, we get the button. Cool. Yeah, that kind of worked. It's the thing to the left of the dot. When we bind our event, the thing to the left of the dot is the button. Now let's do something interesting. Let's, instead of calling the console logging this.name right away, we'll do a set timeout. We want it to happen in 100 milliseconds. Okay, so now we have this ninja out here, and when we speak, we will set timeout. And then when we call this.name, well, what's the thing to the left of the dot here? Well, here's the function that defines that scope. And the thing to the left of the dot then is, well, the global scope. We created a new scope when we did that set timeout. So here's name. When we speak, we get ninja. When you do obj1 speak, we would expect that to, right here, the thing to the left of the dot is obj1, so we get doctor. But when we create this new scope, now in this new scope, it isn't doctor, it's ninja. So we get ninja in both cases. That's not what we wanted. That's kind of weird. Yes, set timeout creates a new scope. Now, when it creates a new scope, it gets the global scope or the scope that we assign it. So this did not behave the way we expected in this case. Let's take a look at mechanisms that we can use to change this. Call is a great way to be able to pass the this that we want to specify. So when we say speak.call, we can pass in what we want this to be. So we've got a speak, and that's as expected. We've got an object 1, and it does the thing. Here in object 2, we're not going to define speak. Rather, we're going to call obj1.speak, that does doctor as we expect, and obj1.speak.call obj2. So we've passed in our this as obj2. This.name is now obj2, and we get doctor and Skywalker. Nice. We were able to change this with call. Now, the cool thing about call is it changes this as we execute the function. The bummer part is it's, well, as we're executing the function. So let's come back to our set timeout example and see if we can fix it with using .call. Now we've got our obj1, and we know that as we call it, it will set timeout and it will create a new scope. But we're saying .call this, which will set the scope to the scope that we expected. So if we say obj1.speak, we'll come in here, we'll .call with obj1 as our this. And then when this executes, now we get this.name. It says doctor. We get ninja and doctor. But it executed right away. It called it right now. It didn't wait for the set timeout. What got passed into the set timeout is the result of this function call, which is undefined in this case. And so we got ninja and doctor, but we didn't get it after 100 milliseconds. We got it right away. We're making progress, but we're not there yet. Changing this with bind. Now, bind is a great way to create a new function that has this set the way we expect. We're basically creating a closure. Now, this is a fake bind function, just so that we can get the feel of it. If we were to pass in fake bind, our function and our object, we could then say, here's our function and our object. We're going to return a new function. And when we call our new function, we will then execute function.call. So now that we've created this closure, we now have this set correctly in here, and we have a function that we can call whenever we're ready. That's cool. So now when we say obj2.speak, we know that obj2.speak bound to obj2 will now have obj2 as the this that is right here. That's cool. Now that isn't the real signature to bind. The real signature to bind is this, where we call it on a function. function.bind obj this that we want, much like apply, much like call. So now we're not defining our speak method here, but we can say obj1.speak.bind to obj2, and we now have this obj2 speak. That's cool. Obj1 speak works as expected, and we get doctor. Obj2 speak, we've already bound the this to obj2. So what's the thing to the left of the dot? Well, we've already set it to obj2, and so we'll get doctor and Skywalker. That's cool. It worked exactly as we expected. We did .bind, and we were able to create a new function that had the correct this already assigned. Now, you'll probably see a lot of code that says stuff like obj2.speak equals obj2.speak.bind obj2. Why do we do this? So that we can bake the this into all of the methods. If we have a button click event, or if we have other mechanisms where we want to maintain the this when things happen, then we can just bake them into place straight away, and then we don't have to worry about it. That's cool. So let's come back to our set timeout example, and we're going to say .bind this. Now we know that .bind will create a new function that can be executed later. Okay, so obj1.speak, we'll call obj1.speak, and we'll come in here. What's the this when it's obj1? Well, it's obj1. We'll set timeout. Now we're going to .bind this. We know that's obj1. So when we get a new function, return to set timeout, that has this bound to obj1. That's perfect. Now, after 100 milliseconds, we'll call it, and this is already bound to obj1, and we get doctor. So in this case, we get ninja and doctor. And it ran in 100 milliseconds. That's cool. I think we fixed the problem. Very nice. When we said .bind, we were able to grab the current this and assign it to our function, and then return a new function that set timeout could call to resume that previous scope. That's really cool. Changing this with arrow functions. Arrow functions are great. Arrow functions are a lot simpler. You know, this arrow is a whole lot less characters than the big word function. This will grab the current scope as the function is defined. So we can think of it kind of like a .bind this, but it's a .bind as we build it. The moment that this function is created is the moment that this is captured. Same thing here. The moment that it's created is the moment that this is captured. Okay, so let's come back to our example, and we'll change this with arrow functions. Here's a speak variable, and we've got this arrow function. We're using all of the ES6 things. We're not typing out the big function keyword. What happens in this case? Well, as we define this variable, this gets grabbed as our global scope. We created this var here that is in our global scope. So when we call speak, well, it's ninja. What about obj1 speak? Well, we call it, and the thing to the left of the dot is obj1, but as we're in here, we've already bound this using the arrow function. So this is still ninja. Same thing with obj2. We're going to get ninja, ninja, ninja all the way through. Yeah, we did find and replace in our code base. We replaced function with arrow functions, and now nothing works again. Because, well, this grabs the scope at the time it's created, not at the time it's executed. Okay, well, we learned that bind can do some interesting things. So let's come back to our great trick bind and see if we can fix this. obj2.speak equals obj2.speak.bind obj2. But we still have our arrow function here. This arrow function captures this to be our global scope. Now we're binding with a new closure around it, trying to set it to obj2. Okay, so when we call this speak function, we have it bound to obj2, And then when we come in here, it's already bound inside that to the global scope. And so, yeah, we still get ninja, ninja, ninja. Once we've bound this, wrapping it in another thing, we're still bound to that original thing that we have in our inner scope. The moment that you grab arrow functions, you definitely get that value there, but that may not be the behavior that you expect. Don't just replace function with arrow just to use less characters. Use it when it makes sense to go grab this that you've got in place. So let's come back to our button example. We've got the set timeout and we've got an arrow function. That's cool. So we're going to call obj1.speak. Obj1.speak, this right here is obj1. We're going to create this arrow function that will grab obj1 as its current context. And it won't do anything. It won't execute the function. It'll just return it. In set timeout in 100 milliseconds, we'll call it. And this, now captured by this arrow function, is obj1. And we get the behavior that we expect. Same thing when we call our global function. It will go grab the global scope and capture it. So we get ninja and doctor. That was cool. In this case, an arrow function was a perfect solution right here because it captured our scope. Now, what if we were to change this to an arrow function? Well, we saw how that would actually capture the scope at the point where this function is defined, and that is not the behavior that we want. We choose this inner arrow function because it captures this, and we choose not to make this an arrow function because we don't want it to capture this yet. That's really cool. We defined it inside this execution when this was set the way we expected. Very nice. Any questions on this or on defining or declaring variables or not declaring variables before we jump into the next section? Great, let's jump in. Is the first argument to bind always taken as this? Yes. The first argument in the bind function is always this. Let's go back to bind and let's look at that. Here's that bind, and it is this that we want to do. Now we can pass in additional arguments that would be arguments passed into the function as they're executed. Typically we don't do this. You might see that with call where we pass in arguments. But yes, that is always this that we want to apply. Even if my function doesn't use this, yes, even so. In this function, we happen to use this, but if we didn't use this, it would still be set the way we want. Now, maybe that doesn't matter. And if it doesn't matter, maybe we don't need to call bind. Great question. Thanks for that. So let's dig into the event loop. The event loop is really fun. I'm not sure that I agree that all of these things are cool. I agree. They are just weird. Understanding how they work is really fun, and it helps us build more defensive code. But yeah, they're weird. They're not cool. The event loop. I love this website in that it describes how the event loop works. Let's open this up and start poking at this. I didn't code this, but I love the way it does it. Here's an intro video about how this site works. Let's close that. We have a call stack, we have a callback queue, and we have web APIs, anything that is set to run later. As we execute, we'll execute the entire call stack. And then once that call stack is empty, we'll come back and pull out anything in the callback queue. As we pull things in the callback queue, then we'll empty the stack again and look into the callback queue again. Once the callback queue is empty, then we'll go on to the next thing. As any web APIs finish, they will get set in the callback queue. So here's a function that does interesting things, but let's go grab our own function here. Let's go grab this one. This is kind of the great example of how bad things happen. Now, in this example, we have a counter, and we're going to go loop through this counter, but we're going to set timeout so that we can run that in a second. Let's save and run. So first thing, we set timeout for 100 milliseconds. Now we're going to go loop through each of them for I equals 1 to 10. Now we're still inside the counting function as we do this, but now we're queuing up show events. Now this is waiting for a second, but because we're not done looping from 1 to 10 yet, none of these show events have happened. Once we finish looping to 10, then we'll get some of these things set out. So counting is still going. We're going from 1 to 10 until 10 is done. And then as we expect, once we've got all of these shows built up, then now we're going to start picking them out, and we're going to console log our current thing, of which, yes, we've looped up to 10 here. And so all of the answers here are, well, 10. We tried to grab the current count, but we didn't bind the this correctly. And so what we're console logging is 10 every time. I love how this visualizes that mechanism. And so you can grab any code, paste it in here, and start to run it. Now, we definitely could pause and resume and start to dig into different pieces of it, but I just love this visualization where we have the call stack that executes right now. Once the call stack is empty, it goes and pulls things off the callback queue. Anything that it queues up, like set timeout or database calls, get pushed out to here, and as soon as they're done, then they appear here in this callback queue. So that's that mechanism of the JavaScript event loop. We have the GUI thread that is working on the current stuff. And when the GUI thread finishes, it goes and grabs the next thing out of the callback queue and sets it in place. Any set timeouts, any API calls, any database calls get set in here until they're done. Once they're done, they go back into the callback queue. Grab the slides from robrich.org and click through here to learn or to watch or read more about this and keep learning. So now how does this apply to Node? Well, Node uses this JavaScript event loop for each request. We can think of this like each request has their own GUI stack and callback queue and API queue. Now, granted, there is only one thread, but as we go to handle the content for this request, we'll go drain its callback queue or drain its stack, and then go to the next request, drain its stack, go to the next request and drain its stack. And then as we get back around, now we'll go look in the callback queue and pull out the next one. JavaScript is single-threaded, and though Node really focuses on asynchronous patterns, we still have this mechanism. So what if when we're down here, we're looping from 1 to 1,000,000, counting something? Well, then all of these requests are waiting and doing nothing. It's really important in JavaScript that we yield the current thread as much as possible so that we can allow the other threads to be able to proceed. In this loop, when we're counting from 1 to 1,000,000, every so often, let's say, well, continue on through the loop and then come back to me. Let me queue up the rest of my work into this API queue so that next time around, it'll come back in this request queue. If you've seen this function, you probably see a whole lot of set timeout 0. Why would I want to set timeout 0? Why wouldn't I want to just like keep going? Well, what I'm doing is I'm very intentionally yielding the thread so that other processes can go loop through and do their thing. Set timeout 0 so that we can get another lap and all of the other requests can make progress. And then I'll come take the thread for a little bit. You might have also seen await process.next tick. In more modern versions of Node, you can also say await process.next tick and pass it nothing. Now, the cool thing about await is that it will do all this work and then it will yield the thread and then it will continue on. And I don't need to worry about this. I've still got my same context. That's great. So we have that Node event loop. And that node event loop is really cool in being able to create responsive sites. If we create any computationally intensive content and we stick that GUI thread, that single node thread with that work, then we can in effect freeze out the other requests. We need to do any calculations either on another thread or on another system and get back to the spot where we get back to this and then continue on. Await promise.next tick a lot, and you'll be able to have much more responsive sites. Not that it's calculating any faster or slower, but it is more responsive for all the other threads. Be a good net citizen and yield your thread as often as possible. Any questions on the event loop before we dig into async and await? Great, let's dig in. Async and await is really fun. Async and await in JavaScript is, well, clearly stolen, inspired by C#. If you're familiar with the task parallel library in C#, then you'll already be familiar with async and await in JavaScript. If you've played with async and await in JavaScript, it's kind of magic. The way it builds it is it builds a state machine over the top of promises and generators. The cool part is that those promises and generators will do things like, well, yield the current thread. And we don't really have a yield keyword outside of generators in JavaScript, but async and await creates what feels like synchronous code, but is actually asynchronous code. The compiler builds this state machine. And that state machine knows how to resume the work at the spot where we left off. That is really, really cool. This state machine can be able to do really interesting things. Well, now how do we use our state machine with other code? Do we have to wait until we rewrite everything to be able to do content? Or is there an interop story between async and await and promises? Well, here's a library that I have, and this maybe is an older library. I return a new promise. I have the resolve and reject. I resolve once I'm done with my long task. And so I have code that looks like this: .then, .catch. Yeah. So how can I transform this into async and await? Well, I have this async function, and I want to rewrite that function to be more modern. Do I need to wait for the thens to all get resolved? Nope. An async function will return a promise. So I can await calling that library and do all the things. Here's my async and await code. Now, the cool part here is I now have a regular catch. I don't have to .catch and try to guess. I have what appears synchronous code, but I know that it's yielding the thread in all of these places. That's really cool. So here's my promise calling an async. Now I've built a new function here, and I don't want to wait until we rewrite all of the other code. So where I have this mechanism that needs to call it, I can do just that. Now notice that I'm not doing an await right here. I'm just calling the function. So what is a res? Well, res is a promise. That's really cool. If I call my function and I don't await it, I get back a promise. So if I say .then with my promise, then I can get results. The interop between async and await and promises is built in because async and await is built on top of promises and generators. So here's the other solution where I have an async function that I want to call into a promise. I've rewritten the outer code and I want to call into my legacy code. Do I need to wait until I rewrite my legacy code? I don't, because async and await and promises has a great interop story. Now, what's going to return here is a promise. I know how to await a promise, so I can just say await. If your code returns a promise, you can await it. And if your code assumes to consume a promise, you can create an async method that uses that. That's really cool. Here's our mechanism where we can await that function, and the function just returns a promise. Or in this case, where we have an async function and we just need to .then once it's done. Async and await. The interop story between async and await and promises is built in. I can await an async method, and I can then just .then once my async method is done. So how would I do that? How would I use this knowledge to run many tasks in parallel? Now we know that JavaScript is single-threaded, so these aren't actually in parallel, but they are in effect in parallel because they're all in that callback queue. So I want to call library 1, library 2, library 3, and they're all built like this, where they're async methods. So they're going to go start their things and go off and do stuff. Now notice that I'm not awaiting any of these. I now have a list of promises. Well, I know how to get a promise that I can wait for based on an array of other promises. So I'm going to say promise.all, and I'm going to pass in that array, and I'm going to then spread the results back out. And so now, given all three of those promises, I will await for the first failure or all success, and I will get my results. Knowing that async and await and promises have this great interop story, I can just flip back and forth between them, and now all three of these tasks are executing in parallel. I'll then return all of these results, and away it goes. Or because I'm awaiting for the first error, whenever the first error happens, I'll be able to catch that error and return immediately. Async and await together with promises works out really cool. JavaScript. It's not bad for a 10-day project 25 years ago. It is an amazing thing that Brendan Eich was able to pull off. It is weird, but we dug into a lot of scenarios where we saw how the weird works, and now it's less weird or a little bit more discoverable. We can think through it like the compiler, and we can understand how this weird behavior came to be. Hopefully now, as we think through it, we can get to a spot where JavaScript can become our friend again. This was really fun getting to share with you the weird parts of JavaScript. I love digging into all of these different details. For those watching the video, hit me up on Twitter at Rob_Rich, and you can grab the slides right now on robrich.org. Click on presentations. For those of you who are here live in the conference, what are your questions? What are your thoughts? What are your feedback? How do you find these problems in real code? Yes. How do we find these problems in real code? Unit tests are definitely our friend. And I love that both the Node and JavaScript ecosystems have a rich focus on testing. If you have tests around your code, then you can discover this unusual behavior. Thinking through it, we were able to figure out how this works, but it may not have been intuitive at the first go. So the other way that I discover this code is as I'm writing code that may not be intuitive on first glance, I will very carefully document those pieces so that then future developers, which is usually me shortly after I've forgotten how it works, can understand how that works and can start to discover it just by reading the comments. Now, granted, comments can get out of date in interesting ways. And so assuming comments may not be a great mechanism, but how do I discover how this works? Based on my tests and based on my comments. Great question. Thanks for that. I do agree that async and await are cool, stolen and improved, but cool. Yes, I agree. Async and await. I hope more languages steal this concept because that automatic state machine where you can kind of think of it synchronously, but it actually works asynchronously is a really, really powerful metaphor. Really enjoyed this. Useful to see something else from my mostly C++ point of view. I agree. Thanks for joining us. That was so fun. In particular, are there tools to detect that this is actually the global scope situation, which might appear to work until there's more than one instance? Ooh, good question. Is there a way to discover that the this in question is the global scope? I don't know of any tools to be able to discover that, but I would argue let's take a little bit of a different stance. Let's look instead at making sure that all of our variables are defined in the scope that we need to use them. ESLint is a great tool to be able to lint our JavaScript and take a look at all of the it's a static analysis tool, but it can look at all of our source code and it can identify if variables are undefined. Now, at that point, we can say, well, if this variable is undefined, it may start to crawl up the scopes and pull a variable out of the global scope. If we run ESLint, we can say, if this variable is undefined, bad things may happen. Let's instead define it in this scope. Now, what it can't identify is if you've defined it in an outer scope and misused it in an inner scope. There is an ESLint rule that says don't allow redefining variables of the same name in inner and outer scopes, but it's difficult to find variables that have where I'm misusing it in an inner and outer scope. Just knowing that my variables are defined correctly, though, will eliminate my dependence on the global scope. I would say in most cases, if you're reaching for a variable in the global scope on purpose, you may have made an architectural mistake. Instead, try to define your variable as close to where you're going to use it and grab ESLint to validate that you've done so. And then the fact that the global scope may have some content in it is kind of irrelevant. ESLint is a wonderful tool. Is this used in best practice JavaScript code for some definition of best practice? Good question. This is a really interesting concept, and it's a really powerful tool when it's used correctly, but it's often misused. And so if you're depending on this, maybe you might want to make different choices. A lot of SPA libraries, Angular, Vue, and React, are moving away from class-based components to functional components so that they don't need to have a this. Now, we still do need to pay attention to this and bind it correctly, but with functional components, all of our variables are just defined in the function or passed in through hooks or parameters. And so for the most part, now we don't have classes that have something to the left of the dot. We've kind of skirted around this issue. This still exists, and understanding how it works and using it correctly is really powerful, but not having code that requires it may make your code simpler and easier to read. Is this a best practice? It depends. It's really powerful, but it's not super intuitive if you don't understand how it works. So you might have more success avoiding it. Great question. Thanks for that. One of the questions I often get is, how do I validate that my code works across browsers? Now, what's really cool is that for most JavaScript engines, they work pretty much identically. So if you're using older features, you can pretty much assume that it works correctly in all the places. Now, you do need to test your interaction with the DOM because those parts are very different, but HTML5 browsers have become much more consistent. The HTML5 spec now defines error handling within browsers, and so even that is more consistent. You can use feature detection to validate that your JavaScript will function correctly just by reaching into things like, is type of navigator defined? Is type of navigator dot the function that I need defined? And using those types of feature detections can allow you to gracefully enhance your site if the browser supports these pieces. Another way to do it is to transpile your site from a higher JavaScript subset to a lower JavaScript subset. So for example, you might set your Webpack rules, Babel rules rather, to transpile from ES 2020 to ES 2018 if your users may not support that. Now, I kind of like to assume that browsers are evergreen, and that's pretty cool, but it has bit me from time to time. And so if you must, transpiling it into ES5 allows you to pretty much support every browser, even IE 11. Now, there are ways to be able to split that apart to say, well, I've got script type equals module for modern browsers, and I've got a script type equals text JavaScript for non-modern browsers. That can lead to some interesting dilemmas now that you've got two code paths and two different paths to test. But if you can leave those legacy browsers behind, then you might have an easier path. But tools like Babel allow us to transpile from a modern version of JavaScript to a more legacy version where we know that things will be a little bit more compatible. The site caniuse.com is a really elegant resource to be able to say which browsers support this type of function. One question I often get is about the WAT video. Yes, if you've not seen the JavaScript WAT video, we looked at it a little bit earlier where, not that one, Brendan Ike displaying the WAT video. This is a really great video where he's just in a very comedic style poking fun at JavaScript. And I particularly enjoy this iteration of it because it's Brendan Ike playing the video and commenting as it goes. It's really cool. I invite you to go grab these slides from robrich.org and click the play button. I won't play it here, but it is such a fun watch. It is really exciting. Thanks everyone for coming. This has been so much fun getting to share JavaScript, the grumpy parts with you. As we think like a compiler, we can figure out how those weird parts work, and I hope they become a whole lot less mysterious to you. Grab these slides from robrich.org, hit me up on Twitter at rob_rich, and let's continue the conversation. Let's continue learning. Thanks for coming.